Welcome to IQT Explains, a series on IQT podcast where we explore technology trends and their impact on national security to provide insights and unique perspectives. I'm your host, Jon Chait, and today we're exploring critical minerals. Let's think for a second. If you had an iPhone, any smartphone, the need for a CAT scan or MRI, our national defense and the systems they depend upon, radars, satellites, all of these actually share a commonality. They all depend upon critical minerals. It's an interesting topic because we're thinking a lot about strategic industrialization these days and the concept that we need to have secure and resilient supply chains for these. About $4 trillion of the U.S. economy is actually based upon different systems and goods that require critical minerals in the products that we create and use every day. So unpacking this and trying to understand what a critical mineral is, though, goes way beyond my ability. So I brought in two experts to help today. One to my side, Russ Ross, VP of Technology at IQT, a technology architect and a physicist by background, I believe, too.
That's right.
Sahil Tapiawala, the CEO of Atomionics, an IQT portfolio company that is focused on areas of critical mineral discovery, and we want to learn more about what they're working on, including the land of quantum sensing. So we're going to have a lot to unpack. Let me start for a moment with Russ. So about 54 critical minerals defined in the latest draft from U.S. government in terms of what we recognize. How can it be 54? What are critical minerals?
Yeah, that's a good question, and a lot of people are thinking about it, John. And where we actually start to define what a critical mineral is that it has a criticality to our economy, right? What are those things? What are those goods that are being sold? And then what are the materials that are used in the manufacturing of those goods? And not just that, but if there is a critical element that enables a product to work or perform in a certain way, and we start to look at not just consumer goods, right? As you said earlier, the phones, microelectronics, all of those, but also defense goods. Things that are used in radar and other night vision systems. And so we start to look at those supply chains further and further upstream, and the actual elements that enable that electronic process to work, or an optical process. Those are what are critical to the technology.
So we mentioned a smartphone before. We all have one of these. I think it's about 5 or 6 rare earth elements are also involved in either inside in the production of a smartphone, or even the glass that we think of that's so nice and polished and we're able to use touch upon it. There are rare earths involved with actually the polishing of that glass, so it comes out the way that we're used to. What's a rare earth then? Is that different than critical minerals, or the same?
No, they are a set of elements within the critical minerals landscape, right? There's about I think it's on the teens of these things that are called rare earths. They actually are heavier elements that have an orbital structure. We won't get into that too much, but it allows them to act in a very particular way in electronics, and as well as in structural materials. It just it enables a whole different set of properties for materials that we use in every day. So the rare earth that goes into the polishing, it stands up to that aggressive lapping against the screen, right? And is able to wear down the glass.
So special strength, special properties like magnetics, strong magnetics for specific applications of sensors, et cetera, all available. Sahil, you once told me, I think as we got to know each other, that a book inspired you to try to move into this industry. Not everyone decides that they want to have a career path initially in the mineral or in the resource industry. How did you get drawn in?
Yeah, that's a great question. It was a meandering path, and maybe I'll backtrack a bit as to how I even got involved in Atomionics. Before Atomionics, I trained as a chemist and an electronics engineer, and my world was one of robotics and multi-material 3D printing. I was fascinated by materials, at the same time was deeply interested in robotic systems. But one fine day, as I was reading this book called The New Map by Daniel Yergin, it spoke about the amount of metal that we actually need over the next 10 to 20 years as we move towards an energy mix that includes solar, wind, as well as conventional energy sources. But beyond that, even for electric vehicles, as well as the data centers that we are looking to build as AI factories, all of these require 500% more minerals to enable that. These minerals are going to form the bedrock of the infrastructure that needs to be built um, over the next 10 to 20 years. For example, we need as much copper in the next 10 years as we did in the last 120. Now, these are some exorbitant numbers. And the key challenge that we realized was that resource exploration is based on trial and error. And majority of this massive delta between demand as well as the supply that we have right now means that we need to find new deposits of minerals as well. But 90% of the drills that we do are empty and they're in the wrong place. And that's why it takes decades to discover a deposit. And this was the problem that we set out to solve at Atomionics. And this is actually what got me excited about the whole domain of geology as well as like resource exploration.
Wow, great background. In terms of where we find those resources, feedstocks, as I think is called in the trade, certain rare earths, very specific ones, aren't available in the U.S., but we seek it amongst U.S. and our allies. We also have those that we might consider adversaries, like China, that are actually, deep into control of parts of either the control of feedstock or the control of the processing or refining to metallization of a lot of these different elements. How about in the U.S.? Do we have active deposits? Do we have the opportunity to perhaps find more in the U.S.? What's Atomionics going to be able to do to help us in terms of identifying these resources?
Yeah, that's a great question. And just to set the background context for what's happening right now in the world, as we were just discussing, 93% of the output for these minerals is controlled by just one country, uh, China. Now, for any form of resilient supply chain, this is actually extremely counterproductive, which essentially means that even though the production of these minerals or like extraction is not happening in that country, the feedstock that is coming from all around the world still ends up in one place. Now, if we need to have a resilient supply chain, the first thing that we need to do is actually find also new deposits while at the same time building out our processing and refining capabilities as well. And this is essentially the area that Atomionics is targeting. How do we ensure that we actually break this hold that one country has on all the feedstock that is available out there? At Atomionics, we are building a planetary map of resources, starting with certain regions where we can help pinpoint and estimate mineral resources. We focus on critical minerals, for example, copper, cobalt, lithium, nickel, zinc, etc., which are going to essentially be the dominant sources in the next few years. Now, interestingly, one thing that we do not realize is that in the United States, Arizona, Wyoming, Nevada have been some of the biggest producers of copper, nickel, and a few other deposits. In fact, until the 1950s, we had some of the world's biggest copper mines here in Arizona. Um, and 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 the United States has a culture and a background in mineral exploration as well as in mining. At Atomionics, what we want to do is map out large areas of land rapidly so that we can compress the time frame that it takes to go from a piece of land to an actual deposit. And so, for context, one of the key things that we have a two-pronged approach to essentially look for these minerals. On one hand, we have built a new way to sense the world around us better. These are called as quantum sensors or quantum gravimeters that help measure gravity. Why is gravity interesting? Because minerals are heavier than the surrounding soil. They show up as anomalies on the gravitational field. These quantum gravimeters can produce 10,000 times better uh, gravity data sets. This gravity is then analyzed by our AI model, which we call as a large planet model, to create a 3D map of the Earth's crust that helps pinpoint, estimate, as well as identify the grade of the resource present underground. We've managed to squeeze an atomic physics lab into a basketball-sized sensor.
Boy, we are lucky to have a chemist and a physicist in background to help us try to understand this, because now we're talking about quantum, critical minerals, rare earths, a pretty broad landscape. Russ, how is such a broad landscape do we think about investing in this space? How do we think about where we want to select ventures and build? How long has IQTEL been looking at this and building a practice around critical minerals?
Yeah, we've been looking at this for a while now. I believe our first investment was probably about 2020. A lot of this critical minerals, a lot of the supply chain pitches that we're hearing from entrepreneurs in the startup community, it really started to flow right about post COVID, right, post pandemic. A lot of folks' eyes were drawn to the supply chain challenges that we had during that time, and then we started to look at, well, where else is the U.S., well, frankly, pinched on supply chain? And so we started to see a lot of that. But really, our investing at IQTEL even started before our first critical minerals investment, because we were actually looking into battery supply chain for more than a decade now and placing investments there. And we had seen where there were troubles in getting cobalt and other nickel and all of these other materials that are so intrinsically needed for battery chemistries and the like. And so we started down that thread and slowly started to make our way into rare earths and others as they became a little bit more in vogue. Yeah.
And Sahil had alluded to the idea that batteries are important and rely upon critical minerals as well. Batteries we think of in our everyday devices. We also think of it in terms of the race to be able to create the greatest AI functionality in the world that can also help to increase our economy. Data centers require having battery as part of their energy infrastructure in order to have continuous power, in order to have efficient power as well. When we think about China then and the turn to it, where again China's quite dominant in the world in battery production. I used the word adversary before. China's a trading partner, but in this particular area, there's some things recently acting like an adversary, and that means I'm trying to light on, the recent pronouncements to first control and then later restrict the export of both the technologies that produce critical minerals, those things not just in the feedstocks themselves, that's part of it, but also in the separation, refining, the metallization, the ability to create the elements in the finished form in applications that we look at too, even in the magnet production, has expanded to control all of that. That has a real serious repercussion to our economy, to the resiliency of the supply chain. How do we think about China where it has the dominant position in the different landscape of critical minerals?
Well, it's fairly complex, right? A lot of these industries that are materials industries are very capital intensive. Require a lot of labor. And so we saw, a definite shift probably post-'80s where a lot of these companies where we had feedstocks here in the U.S., we had processing here in the U.S., we started to see that move overseas towards economies with cheaper labor, maybe a little bit less regulation or an ability to turn a blind eye to some of the environmental effects for some of these caustic processes. And so, it's very large and expansive as to all the different feedstocks that are being processed now in China that they have control over. And then those supply chains that they're starting to build up across the world where they're, reaching out into other countries, setting up relationships, trade relationships, ports, things of that nature. And so that actually is the pinch point for us as we start to think about, well, in a world where we aren't as good a trade partner, because that's the way it's looking right now, with a lot of the restrictions China's put either in the battery industry around the processing or, frankly, those things that are directed towards critical minerals, processing of lithium, processing of rare earth minerals, they're moving slowly and surely up the supply chain, and what that's forcing a lot of the industry in the U.S. to do is they're having to hunker down in China and maybe even do system assembly in China, which it just pulls more of industry away from the U.S. And so I think we need to think about that a little bit more broadly. How do we set that up? How do we make sure that the public-private partnerships that we're seeing here are going to put the capital in place and put a lot of the processing here in the United States? It takes a long time, and I think Sahil, you know this a bit better than I do. It takes a long time to set up a mine, but we do have resources here in the U.S. that we can start to really try to leverage and think a little bit more broadly about, okay, what are the supply chains that we intrinsically need here? And then what are those supply chains that we can partner with allies around, ones that aren't going to set in, restrictions?
So there's a new battleground, in essence, being fought around strategic industrialization because the control of these resources from a feedstock level and forward, and we talked about how many of them there are as well, has a great dependency across the economy. How do we then think of a technology architecture? What's our approach to think of where we want to focus in the investment landscape in this space?
Yeah, that's a good question. And I would agree that there is a bit of economic warfare going on right now. That's true. So as we start to think, or as I start to think about how do we lay the groundwork so that we're organized and we understand what parts need attention, and where do startups actually focus? So with Sahil's technology, really thinking about exploration. Where are those next innovations in exploration technologies to find where the minerals are in the ground, right? Now we've spoken a little bit about the time to mine, right? And you can't just go out and dig a hole. It takes multiple years at this point, a lot of prep work, a lot of regulation and application. But there are mining technologies and a push into automation. So we got to get the stuff out of the ground. We've got to extract the good material, and then we got to separate it, right? We got to turn it into an oxide or separate that oxide from all the dirt, frankly. And with rare earth minerals, right? The reason why they're called rare earths is they're not truly rare. They're just in limited quantity. They're spread out in the Earth's crust, but they're very very small amounts. So you have a lot of dirt to separate. Then after that separation process, we like to think about, metallization is the way you referred to it. I think about it more in the lines of refining, because there's a lot of different critical minerals that maybe don't turn into a metal, sure, right? Like, graphite. I mean, there's certain forms of it, I suppose. But and then the last thing is really about productization. So how do we get those things into the goods? It's normally not, hey, I'm just going to build a jet fighter out of critical minerals, because that's not the case. It's actually the components. So what are those manufacturing techniques, tools to get it into like a magnet form or a structural component or something?
One of the
along
really
those lines.
important application areas too. So across each of these, discovery of feedstocks, like we're about to talk some more about with Sahil and Atomionics, the refining phase, metallization, and then the application of these. Do we invest in each of those categories?
Yeah, we invest across all of those categories, and we have investments in each one of them.
Great. And then feedstocks, I know we've talked about before in the past. It is about the discovery. Sometimes it's terrestrial. There's also the potential to find these types of minerals deep sea as well. There could be the ability to have recycling as a strategy. and even synthetics that could replace some of them. I know we investigated times too. So across each of these sub areas, there's more dimensions that you're thinking about architecturally about where there could be gaps that we could invest in.
Yes.
Great. Hey, Sahil, as we think about the area of feedstock and discovery, and we were talking before about the quantum sensing, is this just a concept? Have you moved it beyond the lab? Is this actually in practice something that can be proven out, how quantum sensing can actually identify and better improve the economics of mining for feedstocks terrestrially?
Absolutely. This is happening as we speak right now. Maybe to set the context, I'm not sure if you guys have seen the movie Dune, but there's a great quote there. He who controls the spice controls the universe. And as much as Dune was science fiction, we live in a world where this quote is still true. Just replace spice with critical minerals. And I think this is essentially what we are trying to resolve at Atomionics. As I shared earlier, discovery and delineation and finding new minerals. And I think Russ also alluded how hard and time consuming this process is. It almost takes a decade or more to discover a deposit and identify what that ore body looks like. And now this is fundamentally because the kind of data that we use is extremely sparse in resource exploration. It is really drilling, which is used as an exploration tool. Practically, what we are doing is using drills as poking holes in the ground and trying to see if there is something over there or not. And if you can imagine doing that, then this would definitely take more than a decade. And so we are rethinking this process of discovery of like where new minerals comes from. At Atomionics, we have essentially built these quantum gravimeters that can help us map large areas of land rapidly and understand what's going on underground before anyone else does, and shorten that process to, instead of discovering one deposit every 10 years, to discovering 10 deposits every year. And that is the ambition that we have at Atmi.
So when we think about quantum sensing, is this an area where you actually have to be attached to the ground and be very close to the surface in order to create a map? Or how do we create a map of an entire state or a nation? Can you do this from the air?
Absolutely. You do not have to just be on the ground. What we are building are quantum sensors that can be deployed on drones. And you can envision a fleet of drones mapping out large states, or doing data acquisition over the whole state of Texas or Arizona or Nevada. Um, and something that would have taken otherwise at least 3 to 4 years to just acquire data can now be done in the span of 3 to 4 months. And that is the ability that allows us to map out large areas of land rapidly.
I think congratulations are in order because you recently secured growth financing. And I think part of the purpose is to continue to work on that shrinking, the miniaturization of the quantum sensing system to be able to become sort of basketball sized and be able to attach to a drone. That enables your ability to be able to go scan from the air. Is that right? Tell me a little bit about your next plans.
Absolutely. We are grateful to have the support of Paspalis, who led the round, and alongside that, BHP Ventures, the venture arm of one of the largest mining companies, also participated alongside Incutel and some other awesome folks. Now, this capital actually allows us to further quantum sensing on three main vectors. One, we are miniaturizing these sensors such that we can now put this onto the size of a shoebox. Practically, we've managed to squeeze an atomic physics lab into this size. Beyond that, secondly, we are expanding our operations to other nations, including Australia, which is one of the biggest suppliers of these metals to the world. Uh, and thirdly, we're essentially utilizing the data to build a large planet model. The same way that ChatGPT is powered by an LLM, we believe that we can essentially build a large planet model that can be something like a ChatGPT, but for the Earth's crust.
Your goals, though, I think go beyond just being a service provider where someone can query. You actually see the way that you can start to penetrate and extract more value out of the mining supply chain, acting in a sense as a junior miner. Can you explain a little bit how your business model works and how the industry is organized?
Yeah, definitely. Right now, if we look at how the industry is organized, there are the major mining companies, or the large mining companies like BHP and Rio Tintos of the world. These are mining companies that focus on extraction as well as some part of exploration. But beyond that, there are a set of companies called junior exploration companies whose sole role is to essentially go out there into the field and look for new minerals. At Atomionics, we are essentially supporting some of these mining companies and going full stack in exploration, going from a piece of land to ultimately discovering an ore body, which essentially becomes a financial asset. And our business model also revolves around, aligning our incentives with the incentives of our partners, and essentially have some skin in the game by helping these companies find these deposits faster and benefiting from it by getting a percentage of some of these deposits that we help discover.
So you're not thinking of becoming like a $10 million or $100 million revenue company. Are we talking billion and billions here of value that Atomionics could be unlocking and participating in?
Absolutely. Fundamentally, we believe that there is a potential to build $100 billion company to even $1 trillion company in the space of minerals and metals. But it goes beyond that. Resources that help power uh, humanity, not just today, but also in the future. Beyond minerals, this can be used for geological hydrogen, geothermal, and any other the source of commodity that we might need from the underground. This tool can help us get there. And this is essentially the company that we want to be. We want to be that company that essentially helps provide these resources for not just our generation, but the next future generations as well.
A perfect example, Russ, of the power of an entrepreneur to take on new opportunities where innovation can actually unlock value.
100%.
Can you help speak to a little bit? Because I know Sahil is appreciative of how our critical minerals portfolio sort of works together and has an overlap. Can we share the spotlight to talk a little bit also about some other examples of companies that we've invested across the landscape outside of feedstock as well?
Outside of feedstock,
Yeah.
Outside of exploration.
Outside of exploration, yeah.
Okay. Yeah, we've actually, I believe on our website, we have quite a few. One that's probably near and dear to your heart is Phoenix Tailings. It's, really coming up with something innovative around separation and refining, right? So how do we get at these rare earth minerals, and how do we do that here in the United States? We have other ones that are thinking a little bit further about, well, what's next-gen separation look like with Alta Resource, in looking at how can biological proteins be produced to be selective to a rare earth element, right, or other critical minerals. So how can it, in a dilute fluid, just grab that one atom, right, and then and contain it and separate it. We have ones that are in deep sea mining, enabling new business models there. It's quite expansive, and we've also looked at how do we separate lithium, right? How do you do that efficiently and not deplete brine that's in groundwater, right? The aquifer. So we have companies in that. We have companies looking at recycling minerals on the end of the supply chain. So like after the product's been thrown away, how do you get those minerals back out of them?
So regenerate the feedstock.
The feedstock. And even a step further than that, we have ones that are thinking about, well, magnets, right? How do we, if that product has a magnet in it with rare earths, how do we turn that into a new magnet? How do we make sure that it gets back into the supply chain? Similar to what you've seen in like lead acid batteries, where like over 96% of all lead acid batteries are recycled, right? Which is incredible. I think we should be striving to do that in all of these supply chains, reintroducing the materials. Yeah.
So important to understand there the role that IQT takes in order to identify key areas to invest in, how to then pick out the great entrepreneurs like Sahil and others that are building in this category, really valuable companies that are moving at the speed and scale to make national impact, to secure a resilient supply chain in order to be able to have access to these minerals that build the products that we all depend upon, and that we depend upon both in everyday life, in our infrastructure, and also in defense systems that are important to our national security. So, Sahil, just want to turn it back to you for a moment. How as an entrepreneur, what other insights do you gain through portfolio connections with us in order to think about the ecosystem, where you should be building, where the opportunities are, and do we think in the future that we're able to build more of this domestically in the U.S. as well, both from the identification of these deposits, the exploration phase that you're so important in quantum sensing, and as Russ mentioned, we have companies like Phoenix Tailings that's soon to operate a refining and metallization process here domestically to create some of the rare earths that are most important in those magnet applications and sensors. Another portfolio company, Novion, I think, building there as well, that then end up in these advanced systems, in the automobiles that depend upon them around motors, electric motors specifically, in space vehicles, in things like our satellites, radar, advanced defense systems, airplanes, et cetera. Sahil, how do you see the landscape and what's happening internationally? Will we be able to secure this back in the U.S. as well?
I'm extremely confident that we'll be able to secure this in the United States as well, not just because of our not just because of the work that we're doing in exploration, but also some of the amazing work being done by other entrepreneurs to figure out refining, figure out processing. Maybe and this has been the key. This has been the key to the success historically, which is in the United States we've always had a technological solution to majority of the problems that we've seen in the past, and I think the same thing also applies for the domain of critical minerals. Historically, the US has been a massive producer and a major player in the domain of minerals. And this I see just as a small blip in terms of where, we've sort of not had a resilient supply chain, but we'll soon get there. Internationally, one of the other main things that we have ongoing for us is, our strength with our allies. Canada and Australia are two of the biggest producers of minerals. They have abundant feedstock, and we have strong partnership with both of these parties where we can essentially also build this together as a strong allied force.
That's great. Let's take a moment.
No, just one step further is, it's an uphill battle, right? We really need to think about the cost competition with the currently entrenched supply chains. And so I think it's a vital time to look towards the startup community, those entrepreneurs with innovative ideas, to figure out, well, frankly, not just how to duplicate it here in the United States, but how do we unlock that value chain? How do we bring down costs so that we can actually be competitive here in the United States and with our allies around the world? I think that's the big unlock that we need to be pursuing.
Yeah, and I'll just add to that, on one hand, we have entrepreneurs figuring out the technical challenges, but at the same time, there are certain things which are happening which are beyond our control. And this is essentially where strong industrial policy comes into picture that supports homegrown solution, as well as policies that protect from unfair practices that are rampant in the domain of critical minerals by other adversarial parties.
So let's focus on the critical part of critical minerals for a second. We've been recapping, learning today about the impact, the reason why these are so important to the economy. Looking also about how the entrepreneur in the innovation space is so critical to this as well. That the processes that are legacy and just the incumbent approaches are not enough in order to secure a future supply chain. And how our allies, too, are important to this vision of how we're going to be able to identify feedstocks and be able to have the processing resources that we need and the applications we need that are important to the economy. So Sahil, quantum sensing we began to learn a little bit about, and you were going to shine some more light for us. What is quantum sensing? How does it operate?
Yeah, that's a great question. Quantum sensors are based on the core technology cold atom interferometry. In cold atom interferometry, we shoot lasers at atoms, and as these atoms interact with the lasers, they give out photons. That's nothing but the kinetic energy of the atoms being lost. And as these atoms lose their kinetic energy and slow down, they're termed as cold because in physics, you end up establishing the temperature of an entity by the vibration or the speed of their motion. At that stage, the wave nature of atoms becomes more prominent. You know how atoms show both wave and particle duality? This is the fundamental quantum mechanical property that we exploit. And we essentially use this matter wave nature to create an interferometer and measure gravity. Now, these systems are used to detect gravitational waves and black holes in the lab. And at Atomionics, we're taking a different pathway by miniaturizing them and deploying them in the field so that we can essentially measure gravity and help figure out what's going on underground.
Fascinating, Russ, how in only a couple hundred years we've moved from basically shaking water in a pan to discover a mineral to cold quantum being the application layer. But Sahil, it sounds so futuristic. What is the state of the art now? What's happening now in the field?
Yeah, whenever I describe something like this, everyone thinks that this is actually at least 10 years away. But the fundamental reality is that, like, in the past 3 years, uh, we've essentially managed to squeeze this into already a mini fridge, and that is being deployed outside in the Arizona desert as well as the Australian outback to figure out what's going on underground with some of the world's largest mining companies. So this is actually happening as we speak. And it is not something that we have to wait for at least a decade.
So you're producing a lot of data. And you mentioned before having an AI model that ties this together. How actually do we resolve distance, size, scale in your system? How do we get down to the level of being able to map the state, map the nation, map the world?
That's a great question. And we've been using gravity since the 1950s to look for things underground. So that is not a new concept. But right now, we are still stuck in the 1950s of data acquisition too. We imagine a box being taken to the field by a geologist. You place that box, it takes 10 minutes to measure one data point. You repeat that every 100 meters for thousands of miles. Now, this is how present day data acquisition works, which ends up taking nearly a year or more to actually capture that size of data set. But if you think about it, if someone tells you that, hey, within these 3 football fields, there is some minerals over there, that is actually not actionable at all. You would end up having to drill through all of those football fields to figure out where that small, veiny ore body that houses the highest grade ore that makes it economical actually resides. And so, what quantum sensing does is that it essentially allows us to measure gravity as we are moving and creates data sets that are 10,000 times higher spatial resolution. So now your pixel that was the size of a football field has gone down to the size of a couple of pizza boxes. And this is essentially what we utilize to create a 3D map. And the interesting thing is that over the past 3 to 5 years, we've had an incredible amount of progress in the domain of vision as well as in the domain of AI. And we are practically applying, the advances that were made in the domain, say for autonomous vehicles or even for detecting your cat, but instead applying it to gravimetry or gravity data to figure out where your next copper deposit is.
Great point, Sahil. And Russ, let's tie that together. We're honored to have entrepreneurs that are able to solve problems like this in the portfolio. The companies that share this element of not just working on new deep tech applications of specialized technology, but how AI is fusing the ability then to utilize that data or improve the processes more quickly to create that economic benefit, have a cost-competitive process in all these different areas. A theme, you think, across the portfolio?
Yeah, definitely a theme across the portfolio and a theme across the larger landscape of critical minerals. We're seeing a lot of companies start to develop techniques and technology that will tie these very, very innovative sensor technologies into useful information. Right.
Well, we're excited and proud to have entrepreneurs like Sahil and others in the portfolio. We also have a shout out and thanks to our co-investors who are helping to enable these important advancements in every area of the critical minerals landscape. So I want to really thank Sahil from Atomionics, Russ from IQT, from helping to shine a light, and a physicist and a chemist to be able to help us break down what is so important in critical minerals. Thanks for listening to this episode of IQT Explains, a series on the IQT podcast. Subscribe for more, leave us a review, and visit www.iqt.org to learn how tech is shaping national security. Thank you.